Okay. Now I thought it's about good timing to look at significant figures, and if you have been told about guidelines, that's good, but if not, here's what it is. So in chemistry, answers are provided to the number of significant figures to the least accurate piece of data used in the calculation. So for example, when you look at the previous question, example question that you might have done already, previous video anyway, there were a few numbers such as 3.00 gram or 1000.0 milliliters of water. Now, which one was more, least accurate piece of data? Well, whichever the one you had to use. 2, all non-zero digits, integers, they are all considered to be significant. 3, zeros between non-zero digits are significant. 4, zeros at the end of a number are significant. 5, zeros to the left of the first non-zero digit are not significant. So when you have like 0.000 and then 13, whatever, those zeros in front are not significant. And finally, I think it's final one, zeros at the end of a number without a decimal point are ambiguous, like 1000. Oops. All right, let's look at some of the examples there. So I've got a series of numbers here written. So firstly, 1000.0, what would that be in significant figures? Well, you have to count these zeros because there's a 0 after the decimal. So 1, 2, 3, 4, and 5. You might see sig fig as its acronym, or just SF. I might start using SF here. How about 1000 gram? Now it's a bit arguable because there is no dot point here, so it's ambiguous, isn't it? So someone might be saying it's just one significant figure, or could be saying, no, they are all integers. So 1, 2, 3, 4. So it could be 1 or 4. Okay, 1.000. Now in this case, it's a bit different. I've been just converting all those 1000 grams into different unit here. So 1.000 kilograms. Now in this case, you have to count this 0 because that's after the decimal value. 1, 2, 3, 4. So this has to be 4 significant figures. Yeah. No, because we've been looking at that, maybe look at this ton as well. So 1 kilo equals to 0.001, and I put extra 0 here to show you that these are not counted, but these 2 are significant. So I said 2. So this number is written into significant figures. How about up there? 32.0, you're including 0, so all that are significant. How about this one? 32 and 00, so 4 SF. Alright, how about these integers here? 1, 2, 3, 4, 5, 6. You have to count all of that. 6 SF, 6 significant figures. How about this one? 1, 2, 3. All the non-zero digits, decimal numbers need to also be counted. So this is also 6 significant figures. Now, if you were using all these numbers in the same calculation, what you would have to do is to stick to the lowest significant figures. Now we said this one was ambiguous, so I'm not going to worry about it so much. In this case, you might want to convert all that into 2 significant figures. Now, how shall we do? Can't do much about 5 significant figures there. Only thing you can do is to get rid of this decimal here. If you do that, it will become 1000, which could be considered either 1 or 4. So it's a bit ambiguous again. But this one definitely can be written into significant figures. 1.000 can be written as 1.0. Because instead of counting 1, 2, 3, 4, you only have 1. But units stay the same. That's 1 kilograms still, yeah. But it's written into significant figures. How about this one, 32.0? Well, hopefully you're just thinking 32 then. Still 2 significant figures. That will be the sign, because instead of doing 1, 2, 3, 4, getting rid of 2 zeros, leaving first 2. How about here? Well, it was already 2 significant figures, so you can just leave it as it is. This one and this one can be converted into 2 significant figures. So let's do that. If you're looking at keeping only first significant figures, which are this and this, the third one needs to be either rounded up or cancelled down. In this case, you've got 6 there, so it can be written as 1, 4, no, 4, not 4, sorry. 4 needs to be 5 now. And the third value onwards will be 0. So 146, 5 to 2 joules can be written as 150,000 joules. This one will behave a bit differently because it's in kilojoules. 146,552. What you do is very similar. 6 will be made up, keeping 1 and next digit. So you should see 150. But if you are working in kilojoules, this was decimals. So all these numbers here need to be cancelled out and become 0, and you don't write that even. 150 is the only number you can write if it was in kilojoules. And this is still in 2 significant figures, or someone could argue that it's still in 3 significant figures. Remember, this 0 is a bit ambiguous. So hopefully you got some ideas of significant figures.